By now, we are aware of the difference between elements, compounds, and mixtures. Do you remember the differences? Mixtures are like food items that we consume. They contain everything in proportion that we desire. We can add or remove a substance according to our need. Compounds, on the other hand, are those which have substances in fixed proportion. So if you change the proportion of substances, it will affect the compound and render it changed. For instance, if you remove even one hydrogen from H2O, that is water, the composition changes and water as a compound does not exist. Thus, fixed proportion is a must in compounds. Lastly, we have the elements. These are the purest forms of any known substance. They are composed of only the same type of atoms. There are neither proportions nor random mixing of substances. So can we say that compounds and mixtures are made up of elements? Absolutely. So in nature, it implies that elements are the basic forms of every material that we find around. And hence, in order to study every substance around us, we need to begin with studying the various elements. So where do we begin? Maybe the reactivity or maybe the physical properties first, right? I'm asking if we can study the reactivity and physical properties of each of the elements. Is that feasible? Well, all these would have been valid only if the elements would be few in numbers. Do you know the number of elements that exist? Astonishingly, the number of elements that we find naturally occurring is 98, while the total number of elements known to mankind is 118. So how do we study each element individually for all its properties? Looking at the number of elements that exist, I don't think it would be convenient to pick every element individually and study all the properties, right? Imagine you have to organize the kitchen. You will not place any vessel or eatable randomly anywhere. You will organize the shelves and refrigerator in the most convenient way which is suitable for your needs. Similarly, for studying so many elements, we need to organize them appropriately. An organization begins with arrangement. Yes, arranging the various elements is the first step towards understanding their properties. And arrangement is possible only if we categorize them, right? This is how we organize the elements. And this process of categorization helps us study the elements with ease. In other words, we've classified the elements here. Classification of elements is categorizing the various elements into groups based on similarities and differences in their properties. The classification system helps us in grouping the various elements into categories which we refer to as the periods. Hence, the system is also referred to as the periodic classification of elements. Let's get to know how periodic classification was carried out in the early days of emerging chemistry when not many elements were known to people. In the upcoming videos, we will understand the various classification systems put forth by the different legendary personalities. It was around the beginning of the 19th century that a famous German chemist attempted classification of the then known elements. It was none other than Johann Wolfgang Dobereiner who did so. He classified the elements known at that time in a particular manner. He placed them into groups having 3 elements each. Do you think these groups of 3 will have elements arranged randomly? Of course not. What's the unique way of placing these elements then? It's simple. Dobereiner arranged the set of 3 elements in such a way that the average of atomic mass of first and third element in the set gave him the atomic mass of the middle element. In simple words, the atomic mass of the second element will be approximately equal to the average of atomic masses of the first and the third element. Let's take an example to understand this better. One of the triads he suggested was that consisting of lithium, sodium and potassium. The atomic mass of lithium is 6.9 while that of potassium is 39. So if you take their average, what would you get? Yes, you get 23, and 23 is the atomic mass of sodium. And this is exactly what Dobereiner had in mind when he framed the triads. However, this is not a perfect method of classification because not all elements follow this principle when arranged in triads. Also, when Dobereiner had put forth the system, only a few elements were known to him. With the discovery of newer elements, this system of grouping elements didn't really work. After grouping the elements in a series of 3, there came a system in which the elements were grouped in series of 8. Yes, this system was put forth by an English scientist named John Newland in the year 1866. There were around 56 elements that Newland could group. He simply arranged the elements in an increasing order of their atomic masses. At the end, he realized that these could be grouped such that every 8th element resembled the first. Astonishingly, the arrangement also stuck an analogy in his mind. Well, can you guess what analogy popped in Newland's mind? Let me help you with that. These are like octaves. Yes, octaves found in music. In case of octaves, we find that every 8th note is same as that of the first one. He found that every 8th element in the series resembles the first in various ways. This is how Newland arranged the elements in a table. For instance, as we can see here, if we consider lithium, then the 8th element after it would be sodium. You would be amazed to know that they both share similar properties. Next immediate examples would be that of beryllium and magnesium. Even these are at positions such that magnesium is 8 places away from beryllium. And yes, they both do resemble each other. With this analogy, Newland named the grouping system of elements as laws of octaves and even Newland's laws of octaves. Although the arrangement pattern was quite good, but it was valid only until calcium and not applicable for elements after that. After calcium, every 8th element did not have properties similar to that of the first. By that time, there were only 56 elements known. Newland assumed that more elements will not be discovered in the future. Many elements were of course discovered later, but did not have properties that could fit in the system in any possible way. Another notable drawback in this system was that cobalt and nickel were placed in the same position. And this position was in the group of halogens like fluorine, chlorine and bromine. But these halogens have completely different properties as compared to cobalt and nickel. With all these limitations, Newland's octaves also had to be ruled out. Later, there came a proper, well-defined system which was put forward by a famous Russian chemist called Mendeleev. He not only gave a systematic approach to classify elements, but even laid the foundations of modern periodic classification that is widely used today. Let's have a detailed look at the periodic classification of elements as presented by Mendeleev in the next video.